Hi, welcome everyone. My name is Flora and I'm your host for tonight. Before we start tonight with the DevOps Meetup Amsterdam, I want to thank Henk Boelman, who made this all possible, that we can still deliver an online sort of meetup experience to you, even though we can't meet in person. So special thanks to Henk. If you follow along on Twitter, we're on DevOps AMS, so that's the Twitter handle that you can use. And Henk's Twitter handle is H Boelman. So if you want to give him a big thank you, that would be really nice, and I am sure that he would appreciate it. Even though we're an online event and not an in-person event anymore, I would still like you to know that the code of conduct is still very much valid. If you're unsure what the code of conduct looks like, then you can go to devopsdaysamsterdam.org /events/2020 Amsterdam/conduct, so you can have a look at what the code of conduct looks like, just if you need a refresher. Comments will be taken after every session, so the selection of the comments will be courtesy by yours truly. So we'll go through the comments during the session, and I'll make sure that the speaker gets the questions in our private control center. And the speakers can, of course, after their sessions, also engage in the YouTube comments. Then, if you'd like to speak at a next DevOps meetup, be it online or in person, who knows, please let us know. If you go to the website of DevOps Days Amsterdam, you can find an email address where you can reach us if you'd like to propose a talk. These talks will be recorded and we'll make them available shortly after. I have a sort of a co-presenter here who's hiding, so this is going to be a great, interesting meetup. Anyway, I'd like to start with Sara's talk. Sara is a backend engineer at DAZN. I've heard that I have to pronounce it that way today, and she'll be talking about failure modes in AWS serverless services. So, Sara, there you go.
Hi, everybody. Can you hear me? Yeah. So my name is Sara. I am a backend engineer in DAZN. I've been a developer over the last 9, almost 10 years. I joined DAZN 1 year ago, and as a backend engineer, I am contributor to shipping, developing, provisioning, monitoring all the microservices that power the DAZN platform. For those who are not familiar with DAZN is nicknamed the Netflix for sport. We stream sport events on real time and in demand. And most of our platform is powered by AWS. And within our architecture approach, we try to follow a serverless first approach. So that means that we try to simplify the delivery of our services by choosing serverless when it makes sense. Otherwise, we roll back to other solutions that can be ECS or Kubernetes sometimes. So today, I'm not going to talk about things like how we made a certain service very performant, or how we made the successes of the team that I belong to. Today I will talk about failures. So let me turn off the notification. Okay. So today we're going to talk about failures, and let's start with simplifying with serverless computing. Apparently, so they say, serverless is great because it simplifies shipping of new services. The alternative would be, if we don't choose serverless, that we have to provision an application load balancer, VPC subnets, EC2 instances, some data storage, whether this be RDS or any like data storage. And if we want to make it also reliable and resilient and highly available, we will have to deploy on multiple locations. And within a region, that means probably multiple availability zones, without even imagine like multiple regions. So I'm not even taking into account active architectures. So this is how more or less as an architecture that is not serverless oriented looks like. If we go with serverless, we have the advantage of creating, for instance, for a REST API, one API gateway, one Lambda, and by creating those those services are already available in all the availability zones. So if I create one API gateway, one Lambda in new Central 1 region, AWS region, that service is going to be available in all the different availability zones of that particular region. And if we have a data storage like DynamoDB, which is a serverless solution for NoSQL databases, we have consistency through all the availability zones. So we have data replication out of the box, and that is a great advantage. So until now, I'd say it sounds like it's the solution to all my problems, right? Well, let's see. Let's start with a particular scenario, which is Lambda asynchronous invocations. When you have two Lambda, you can invoke one Lambda to another Lambda. One Lambda, let's say Lambda A, can call Lambda B in two different ways. You can call the second Lambda synchronously. That means that the Lambda A calls Lambda B and waits for the response. So it's hanging. The synchronous invocation instead just sends the event to the Lambda B, and Lambda A doesn't wait for the response, but it's just acknowledging that the event is dispatched. In the case of a synchronous invocation, what we don't know when we do this is that between Lambda A and Lambda B, there is an AWS managed queue that is in between. It's a proxy between the two Lambdas. So what happens if the Lambda B, if there is a failure in Lambda B, for instance, so the event is not correctly processed, the event is reprocessed multiple times and goes back to the AWS managed queue, and it gets retried to Lambda B by Lambda B a certain amount of time. So let's see a use case of one of the use cases that we encountered in the team that I was working in the zone. So we have two microservices. The microservice that you see on your left is a microservice that is a simple REST API that has an API gateway and a Lambda that gets a post request. And that post request is then processed, HTTP post request is processed, and in a synchronous invocation is sent by the Lambda post items to the Lambda generator. The Lambda generator is part of a microservice that is separated and has processed the information that gets from the previous microservice, and based on that generates some items, sends some email to stakeholders. And as part of the initial design, if something was going wrong, we would then send the failed messages, the failed events, to a dead letter queue. A dead letter queue is the managed queue that you can set that receives all the messages that were failed more than 3 times. This is an option. And yeah, so these are the limitations that we found. Every error was retried 3 times, and after 3 times, that message event would have been parked in the dead letter queue, which is the SQS one that you see. So everything looked good until we tried to promote our microservices to environments that were like staging. And so they were not our dev environments, they were more mirroring production. And the first thing that we noticed is that there was an abnormal number of timeouts on stage in production. I say production because we were not live yet, but we were released into production as part of a dark deployment before the official release. So at this point, we were not live yet, but we were deploying. And so we noticed that there was an unusual number of timeouts. And what we figure out is that actually at the time, because we were testing so much the dev environment, the dev Lambda was always very warm. And as I don't know if you're familiar with Lambdas, but there is a problem with the Lambda being warm or cold. If you don't invoke the Lambda frequently enough, the first time that you're going to call Lambda is going to take some time to get to process the request. Oh, sorry, not the request, but the event. So we noticed this. Another thing that we noticed is that we were unable to customize a number of retries, and that was a bit of a limitation. If you have like certain requirements for your service that you want to have more or less a number of retries, that's a limitation that at the time last year we didn't have. Another limitation was that from a Lambda perspective is that there is a hard limit of 50 minutes for the Lambda. So Lambda is great if you want to process a very short amount of time, computing that takes a short amount of time. And in this particular scenario, we had a new requirement that would take more time than 50 minutes. And that was also that also got worse because of the coldness of the Lambda itself. So in that particular scenario at that time, unfortunately, we had to migrate from Lambda to an ECS-based architecture, and that is our output. So instead of a Lambda, we had to roll back from serverless, and we had an ECS poller, long poller, that would be integrated with an SQS queue that we ourselves provision, and the SQS dead letter queue that was already there. But good news, because since then, since last year, AWS changed this. So at this time, you are able to customize the number of the retry attempts. So now you can be between 0 and 2. It's still a limitation. So I think it would be nice to make the number of retries a bit higher, but that's something. Also, you can customize the number of age of events. So the time of in which the Lambda keeps the event into the managed queue up to 6 hours, which is great. Another nice feature that they rolled out recently is the Lambda destination. So you can decide when a Lambda takes an event, from an asynchronous invocation. You can decide where this event will be dispatched as destination, both in case of failures, but also in case of successes. So that's great. Let's see another scenario, event source mapping. It's very similar to a synchronous invocation. In this use case, in this architecture, we would have one microservice that would have another REST API endpoint. In this case, the serverless solution was global DynamoDB table that would contain items integrated with Lambda via event source mapping, which is the Lambda data reporting. So the right side of your screen is a flow that is architected to do some data reporting for our data team. And the way event source mapping works is that all the changes that are performed over the records of the DynamoDB table would be then transformed into streams of records that are then processed in batch by the Lambda. And even in this case, there is a managed queue that you don't see between the global DynamoDB table and the Lambda that is managed by AWS. Notice that also in this case, you can customize, you can have some things that are out of the box, but there are some services that are managed by AWS that you don't have power on. So everything in there happens between the global DynamoDB and the Lambda is managed by AWS. And in this case, something that happened is that we were noticing that we were not getting any data in our S3 bucket. So ideally, everything that was coming from DynamoDB was processed by the Lambda, that was processed by Firehose, that was ingested then in a S3 bucket, which is a data storage, where we would store some data in form of JSON. We noticed that we were not getting anything in the S3 bucket anymore. And what we noticed is that there was an error happening in the Lambda, and that error was basically keeping the managed queue that was between the global DynamoDB and the Lambda, and was blocking the process of new incoming records. Upon further investigation, we saw that there is an option to set up a destination for anything that fails in the Lambda, and it is possible to not put any on failure scenarios. So this is something not very optimal. I believe that AWS should probably make this on failure destination required, and the retry attempts. So if something would happen that's wrong in the Lambda would retry the same event continuously up to 10,000 times, and every time would be with exponential backup. So every time between each iteration would take longer, and that would block the entire queue. And that's not really optimal, because in case of failure, the batch is, as I said, in case of failure inside the Lambda, the batch is retried until either there is a success or the record expires. So these records will be processed or try to be processed up to 24 hours, and then they will expire, so you don't have them anymore, or the max retry limit is reached. This means that, you can block the entire process for up to 24 hours, and you can even lose data, and that's not really optimal. Another scenario is related to batch operation to DynamoDB. So between an ECS container, ECS task, and ingestor, let's call it ingestor, and a global DynamoDB table, we were trying to add some items in the table. And upon further investigation, we were trying to see, okay, how were things handled from a AWS side if something goes wrong while writing to the DynamoDB table, because as you know, there is some certain throughput that you have to satisfy when writing on DynamoDB tables. You can't just write as much as you want. So we investigated in the documentation. This is the AWS documentation as it was at the time, and as you notice, the error handling session is very hidden, nested a bit inside the programming with DynamoDB. It's there. So if you want to make sure that you're handling that scenario, it's not really easy to find that information. But if you open the page, this is the list of all the error scenarios that you can, all the errors that you can get by performing operation on a DynamoDB table. And why is this important? It's important because not all of them should be retried. So this is something important. Also, because if you want to write your test, if you want to see, okay, my unit test or integration test, what happens if Dynamo returns this particular error because of this particular scenario, then there is a lot of things that you have to take into account. Obviously, not all of the things in these items in this list are important. Not all of them are not important for the scope of your project. Only a subset of them, but you need to know the things can go wrong, and you need probably, if you want to implement the correct test scenarios, you want to know. So luckily for us, a lot of when you use the AWS SDK in OGS, you can expect that the SDK will take care of a lot of retry strategies for you. One thing that I figure out while working on this is that at the end, the SDK is a wrapper around HTTP calls that are done by the ECS task to the DynamoDB service. And the service is accessed via HTTP. So at the end, the operations are all HTTP calls. All the serverless services that are called using the SDK are accessed via HTTP calls. And the AWS SDK takes care of a lot of those retries, but not all of them. So some of them you have to take care of yourself. Another scenario that we notice is another scenario that we experience, is yet another REST API application service. And in this case, we have like an API gateway with a WAF and integrated with a network load balancer and an ECS task. And something weird happens. So we noticed from our dashboard and from our metrics that the API gateway was returning a unusual number of 500 errors after load testing, during a load test. So we investigated and we noticed that actually our ECS application was not returning any error. So the error was either the API was originated either via the API gateway or the network load balancer. And upon investigation, we checked the error logs, the logs for the API gateway, and we saw that all the errors were actually errors that were network errors that were generated from the API gateway trying to communicate to the network load balancer and the ECS service. So we received a lot of 504 because the API gateway was not able to connect. And that is an error that it's caused by AWS itself. It was not generated by us. And it was very interesting to see that the service was not as available as we expected it to be. We open an API, so we open an AWS support and ticket, and the support, the person in charge of the support to handle the ticket explained to us that at the end, it is normal for AWS service to not be completely available. We expect AWS to be 100% available, but that's not the case. And if you go to any AWS service /SLA, this is something that I also, this thing I learned recently, you have a monthly uptime percentage that is limited. It's not 100%. It seems obvious, but it's not. And if you think about it, if you design your services using different AWS services, each of them has its own availability. So each of them contributes to the global availability of your own service, which is already partially unreliable. So choosing which AWS service is going to be powering or supporting your microservice, it's something that needs to be taken into account, the availability. If you go to the documentation of API Gateway, you will see that AWS tried to bring some guidance in terms of like how to handle error scenarios, including the 504, as you could see. And what is important to see in their documentation is that not all of them should be retried. Some of them not, some of them yes, and some of them only if you retry different times, the result is the same, which is not always the case according to the context. So what are the learnings that we had during this, like each of these scenarios that we saw until now? First of all, observability is a must. To capture failures and to be able to either automate the handling or to react to it in a manual way, you need to have observability, you need to have metrics, you have to have logging. So observability is a must. Sorry. When you shift the responsibility to AWS and you rely on AWS serverless services, you offload certain responsibilities like VPC provisioning or operating system, setting up operating system or setting up clusters. This is everything that you can offload to AWS, but then you also lose control over certain configuration that you might need because of some certain requirements of your service. So you use control over the custom strategies that you might want to implement. This is something that I say often, like to me, writing code for distributed that is supposed to be hosted on distributed system is very tough. And I'd say 90% of my time sometimes 90% of my time is dedicated writing tests, and 10% is dedicated writing the actual business logic, just because the failure scenarios needs to be really captured. And when you have distributed system, you need to take into account that your dependencies might fail, and you need to react to it. Maybe you want to send some metrics, maybe you want to make sure that you're logging everything you need, maybe you want to make sure that you want to retry in case of failures. So if you want to cover these scenarios, it can be very tough and time consuming. As we saw in this journey, default settings of services are not always optimal. Sometimes AWS has certain settings by default that are not super, not maybe the best in terms of resiliency, sometimes security, but it's something that we need to be careful when deploying services. Is you need to read the documentation, and you need to make sure, okay, what happens if something goes wrong? How is my system going to react? This is something great. So in case of HTTP calls, the AWS, in case of calls to different services using the AWS SDK, the AWS SDK takes care of certain retry strategies for you, so that's great. But if you don't use the SDK, you need to implement your own strategies with backoff, and you need to handle different error codes in different ways, as we saw in the API Gateway documentation. Another important learning is that no system is 100% reliable. That includes the systems that are managed by AWS. These might have an impact over the availability of your own service, so be mindful about it. And to conclude, failures can't all be avoided. What is very important is that you need to prepare your system or to implement your system in such a way that the system is prepared to handle them. And that's it. Thank you. Do you have any question?
We have one question in the chat.
Nice. Which is? I'm sorry.
All right, do you want me
I don't have it in front of me.
Don't worry about it. Question is there monitoring in place for the queues? For instance, how long messages are in the queue, and what is a useful metric for this?
Yeah, so there are AWS metrics. Absolutely, yes. So there is the age of the oldest item. So that's very important, because when you park an item inside an event inside the queue, by default, there is a maximum time of retention, which is 14 days, which also it's a limitation. So you need to be careful that if something goes wrong, your failed event is handled before the end of the time. There is another metric which is called max iteration age. And that was actually the metric, the skyrocket, when we were doing the event source mapping between the global table, DynamoDB global table, and the Lambda. So the max iteration age of the Lambda was like millions, and there was, whoa, okay, that's a lot. Then other metrics, certainly failures in the invocation. So if the Lambda throws an error, is gonna generate some error invocations errors metric. So these are the top three that I have in my mind. But then, according to the event source mapping or this particular architecture, you might want to have something else in place. But these are the top three that I have in mind. Any other question?
Awesome. I hope that answered the question. I don't see any right now in the chat, but I propose that we do a little break for everyone to run to their fridge and get some refreshments, and then we'll continue with Stacy's talk. Thank you so much, Sara.
All right. Thank you. Thanks.